All right, Mr. Ahmed here for 8.1 part 2. Goal for today is to use similar polygons, and we're going to kind of take a peek at their perimeters and their areas as well. So the perimeter of similar polygons are going to be in the same ratio as their corresponding side lengths. So if we can find the scale factor of the two polygons, then we can also find the perimeter of the polygons if we know one of the perimeters. Now, I guess that's kind of helpful if I just know one of the sides, and then I know the scale factor of how it's set up, then I could use that to find the perimeter. And we'll also be able to use this scale factor in order to find the area of similar polygons. So as I take a look here at this first theorem, I just want to arrange this here a little bit better. I have a couple too many pieces of paper out. I didn't want to write on top of next week's stuff, so sorry about that. As we take a look at this first theorem here, we take a look and it says that KLM is similar to PQRS. And again, we went with this figure being the original and then this one being the new one. So when we're setting up the scale factor, we want the new over the old. So SP over NK would be the scale factor. All right, that's the ratio of the sides. And that's also then going to be equal to the ratio of the perimeters. All right. I just have to keep in mind which figure is which when I set up that proportion in order to solve. So our first problem here involves a pool. So it says a town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. The new pool will be similar to the Olympic pool, but will have a length of 40 meters. And it says to find the perimeters of the Olympic pool and the new pool. So I'm going to draw out the new one. And obviously that's not a very good rectangle. I could have done a little bit better than that. That looks more like a square. But nonetheless, it's going to have a length of 40 meters. So this is the length. I'm going to make this longer. It just doesn't look very good to me right now. Sorry about that. Erase this piece in the middle. The whole side is 40 meters long. Okay, now it looks a bit more rectangular. So the new one, the old one, and if I were to find the perimeter of the Olympic pool, I would know that this side is 50 because it's a rectangle, and this side's 25. The opposite sides are congruent. So the perimeter of the Olympic pool is equal to 50 plus 50, which is 150. So 150 meters, and that's the Olympic pool. And we are supposed to find the perimeter of the new pool as well. So for us to do that, first we have to set up the scale factor of the sides. And I'm going to go new to old, so that's 40 over 50. 40 over 50. Those are the corresponding parts. And that would reduce to 4 over 5. And then from there I could set up a proportion. 4 over 5 is equal to the perimeter of the new one, that is what we are finding, x, over the perimeter of the old one, 150. Then we can cross multiply to solve, and we get 5x is equal to 4 times 150, which is 600. Then when we divide it by 5, I get 120. So the perimeter of the new pool is equal to 120 meters. And the perimeter of the Olympic pool was 150. So we found the perimeters of both the Olympic pool and the new pool. Next step says, the two gazebos shown are similar pentagons. Find the perimeter of gazebo A. So I need to find the perimeter of gazebo A. So I know that the perimeter of this one is, adding up all the sides, 18 plus 15 plus 12 plus 9 plus 15. I get a perimeter of 69 meters. When I add up all the sides. So I had to find that first. Now I need to find the perimeter of this one. That is unknown. Okay, so corresponding side lengths. It appears as if the 10 corresponds with the 15. So that would be the scale factor, 10 over 15. It didn't say specifically which one's new or old, so I'm good to set it up however I want. So I am going to go 10 over 15. I could reduce that if I want. That does reduce down, but I don't necessarily have to. Equals the perimeter of the unknown one, which is on top, x over 69. Then we will cross multiply to solve, and we get 15x equals 690. And we divide by 15. I got 46. So the perimeter of gazebo A is equal to 46 meters. We got it. It appears as if my pen is dying, so we'll transition to a new one. Okay, on to our next page. Areas of similar polygons. Now, the area ratio for similar polygons is going to not be equal to the scale factor. It's equal to the scale factor squared. Okay, so I have to find the scale factor and then square it in order to set up the ratio of the areas. All right, so it says if two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths, which is that scale factor. So in this diagram, we just kind of took a look. The area of the big one over the area of the small one is equal to the side lengths that correspond squared. Okay, so that's how we're going to set this up. So we need to find the area of DEF. So this is what we're looking for, the area that's equal to x. So setting up the ratio of the sides, 10 over 25. Sorry, 10 over 5. I squared it already. 10 over 5, I'm going to just scratch that off. 10 over 5 squared is equal to the area of the big one, 36 over our unknown area x. Now when I do this, I have to square this first. I'm going to square the top and the bottom. That's the easiest way that I can think of to do this. I have to square both values, so 10 squared is 100 over 5 squared, 25 equals 36 over x. Then we can cross multiply to solve. So 100x equals 25 times 36, and I got 900. Divide by 100, divide by 100, and x is equal to 9. So our unknown area is 9. So the area of triangle DEF equals 9 centimeters squared. Area is squared. Okay. And one more example here of finding the area. So we're supposed to find the area of LMNP. So this is our unknown area equals x. Area of this one is equal to 84. So when I set up the ratio of the sides, 7 over 21, I can reduce that. So I'm going to reduce this right now. 7 over 21 is equal to, actually, let's go I'm going to go left to right. So 7 over 21 is 1 over 3, and that's equal to 84 over x. Don't forget, we have to square. We have to square the ratio of the corresponding sides. 1 squared is 1, 3 squared is 9, equals 84 over x. X equals 84 times 9. When I cross multiply, 756. And we got it. So the area of the big one is equal to 756 meters squared. And that's how we use the area ratio as well. All right, have a good one.